What if everything you see, touch, and experience is not what it seems? What if the entire universe, including you, is nothing more than a vast projection, like a cosmic hologram? This is the idea behind the Holographic Universe Hypothesis. A theory so strange, so unsettling, that it makes us question whether reality itself is an illusion. Is our universe truly three-dimensional, or are we living inside a shadow of a deeper reality? Today, we'll explore the science, the evidence, and the mind-bending implications of the holographic universe. For most of history, we assumed reality was straightforward. What you see is what exists. But physics keeps pulling the rug out from under us. First came relativity, showing that space and time are not fixed but bendable. Then came quantum mechanics, revealing that particles can exist in many states at once, collapsing only when observed. And now, the holographic principle suggests something even wilder. The three-dimensional universe we experience may emerge from information encoded on a two-dimensional surface at the edge of the cosmos. Imagine a credit card hologram. Tilt it, and you see a 3D image projected from a 2D surface. Our universe, some physicists argue, could work the same way. The roots of this idea come from the study of black holes. In the 1970s, Stephen Hawking discovered that black holes are not entirely black. They radiate energy, now known as Hawking radiation. But this created a paradox. If black holes evaporate, what happens to the information about everything that fell into them? Physics says information cannot be destroyed. But black holes seem to erase it. Physicist Jacob Bekenstein proposed a radical idea. He showed that the amount of information a black hole contains is not proportional to its volume but to the area of its event horizon, the two-dimensional surface surrounding it. In other words, the information about everything inside a black hole could be stored on its surface. Like a hologram. Later, physicist Gerard T. Hooft and Nobel laureate Leonard Susskind expanded this concept to the entire universe. If it's true for black holes, they argued, maybe it's true for everything. Maybe our whole universe is holographic. At first glance, this sounds like science fiction. But the holographic principle is grounded in real mathematics. In 1997, physicist Juan Meldacena gave the most compelling formulation. He proposed a model where a universe with gravity in 3 dimensions could be mathematically equivalent to a universe without gravity in 2 dimensions. This is known as the ADS/CFT correspondence. It suggested that 2 different realities, one with gravity, one without, could describe the same universe. One on a flat surface. One inside a volume. The 3D reality we live in might be a projection of data stored on a 2D boundary far away. This doesn't mean we're living in a video game or computer simulation, that's another hypothesis. The holographic principle is deeper. It's about physics itself. Reality may be information at its core. What evidence do we have? Some hints come from studying the cosmic microwave background, the afterglow of the Big Bang. Certain anomalies in its patterns could be signs of holographic structure. Other experiments probe the fundamental limits of space and time. The holometer experiment at Fermilab, for example, tried to detect holographic noise, tiny jitters in reality that might indicate space-time is pixelated at the smallest scales. So far, results are inconclusive. But physicists continue to test. Even if evidence is subtle, the mathematics keeps pointing in this direction. And mathematics in physics often reveals truths long before experiments confirm them. But what would it mean for us? If the universe is holographic, then reality as we experience it is emergent. The world feels three-dimensional, but it may arise from information encoded elsewhere. Think of a video game. On screen, you see landscapes, characters, entire worlds. but underneath, everything is ones and zeros, stored on a disk. The holographic principle suggests something similar for the cosmos. Does that make our reality less real? Or just different from what we assumed? The holographic universe also ties into deep questions of consciousness. If reality is information, is the mind also information? Could our thoughts, our very sense of existence, be part of the holographic projection? This connects physics with philosophy, and even ancient ideas. Mystics across cultures have described reality as an illusion, a shadow of a deeper truth. Now physics is beginning to echo that possibility. But there are limits. Not all physicists agree. Some argue the holographic principle is a powerful tool for solving problems in string theory and quantum gravity, but not a literal description of our universe. Others think the evidence is too thin, that the idea may never move beyond speculation. And yet, the principle has already changed how we think about space, time, and information. Even if the universe is not holographic, exploring the idea has revealed connections between gravity and quantum mechanics, two pillars of physics that we still struggle to unify. So, are we living inside a hologram? We don't know yet. But if the holographic principle is true, the implications are profound. Reality is not what it seems. Space, time, and matter are emergent, not fundamental. The universe is not a stage for information. The universe is information. And perhaps the biggest question of all, if reality is a projection, what is the surface projecting it? Where does the information live? And who, or what, decides how it unfolds? Every second you exist, you participate in this grand projection. You live in a reality that may be both real and illusory at once. A universe where everything is information, encoded at the edges of space, playing out as the vast cosmic drama we call reality. So, what do you think? Is the universe a hologram? Or is the holographic principle just another beautiful but flawed idea? Subscribe to ScienceMined for more mind-blowing science facts every week. Because when it comes to reality, the greatest mystery might be whether it exists the way we think at all.